Charge and current. Charge, current and potential difference. Charge, given the symbol capital Q, is a property of matter which can be positive or negative and is measured in coulombs, symbol capital C. Electrons have a charge of minus 1.6 times 10 to the minus 19 coulombs, whereas protons have a charge of plus 1.6 times 10 to the minus 19 coulombs. If an object has equal positive and negative charge, it will be neutral. When charge flows, we have what is called an electric current. In a metal, it is free electrons which carry the current, whereas in an electrolyte, the current is carried by positive and negative ions. Here we have a representation of a very simple circuit involving a cell and a lamp. And let's consider a charge here, Q, carrying energy E around the circuit. Now the charge will deliver its energy to the lamp and then collect more energy from the cell. In reality, lots of charges will be passing all the time, and the lamp will stay lit constantly. In reality, many billions of charges would pass through the lamp every second, depositing energy, and the lamp would remain lit constantly. Notice also that no charges entered or left the wire, so the same number of charges would be passing here as here, for instance. Note that the charge carried on round the circuit to collect more energy. It didn't escape, and we didn't create or destroy any charge. Here we have basically the same circuit, but now this paddle wheel will represent the ammeter, this being the circuit symbol for an ammeter. As the charge goes around the circuit, the ammeter counts the passing charges. The charges are still collecting energy from the cell and delivering it to the lamp, but now they're being counted as they travel. The ammeter is measuring the current in amps, and current is the rate of flow of charge, or in symbols, current I is equal to delta Q by delta T, where delta Q is the change in charge or charge passing, delta T the time that has elapsed. The coulomb, given symbol capital C, is defined as the charge passed when a current of 1 ampere or 1 amp flows for 1 second. The ampere is defined by its magnetic effects, and this is not required for AS. What we've been looking at so far has been what is called conventional current, where we consider positive charges moving from the positive round the circuit to the negative terminal of the cell or battery. In reality, when more was learned about the nature of electricity, it was found that electrons travel around from negative to positive, transferring energy, rather like this.